Good morning, everyone. Today we'll be talking about MLB baseball statistics. I'm Marley.
I'm Jenna.
I'm Kyler.
And I'm Daniel.
Okay, so MLB baseball statistics. This is really important because sports analytics is on the rise, especially with majors like business analytics becoming more relevant. And so sports analytics is the analysis of sports data, including components of sports such as player performance, business operations, and recruitment. And teams are using sports analytics to evaluate not only their own strengths and weaknesses, but also their opponent's strengths and weaknesses, which can make them a much more powerful team.
The data we used was from a Baseball Savant website, which we used the major league teams, Brewers, Pirates, Cubs, Reds, Cardinals, and Red Sox. So we grabbed about 16 players from each of those teams that made up our 100 observations. We also just want to express our information to baseball managers and coaches because this information is going to be the most relevant when looking at how to make your team better and how to create success for your team in the future. And then we tested our hypothesis test for statistical significance and then made conclusions based on our p-values. And then the variables we used today were salary, age, position, batting average, average runs, and then on-base percentage. The first hypothesis test we conducted was positions played versus batting average. So we wanted to see if there was a relationship between the certain positions and the batting average to see for managers and coaches if they need to hire a certain position that had a good batting average. So the variables we used were batting average and positions. So positions such as first base, second base, third base, corner infield, catcher, excluding pitchers though because they do not hit. And then for batting average, that is the total amount of hits divided by the at-bats, and that will create a number. And then looking at our graph, we have position on the x-axis and then batting average on the y-axis. Throughout the whole graph, you can see that most of the positions have a similar batting average, but corner infield having the most at 0.27. So throughout the whole graph, positions don't really affect the batting average. The statistical inference we gained from it was a p-value of 0.696, and then that would be greater than 0.05, so we failed to reject the null hypothesis. What this means is that when managers and coaches are looking to hire players, they're not going to look at positions and batting averages together. They're going to look at specifically what positions we need for our team and then how those positions can better our team. And then they're going to look at batting averages as a whole per player and to see how the batting averages can help wins out for the team.
All right, and then next we wanted to look at whether age affects a person's batting average. So for the variables for this was age, which is obviously a person's age, and then batting average. So total amount of hits under the total amount of at-bats. And so you guys can see here, there's not much correlation at all. All the plots are just scattered around. And then I did not have to filter anything at all. There was no outliers or anything. So all the data points that we had are on this graph right now. So I got a p-value of 0.443. So this is greater than our 0.05. So that means we failed to reject the null hypothesis. So this just means that our data is not strong enough to suggest that age affects a person's batting average. So through my testing, I got an R-squared value of 0.006. So if there is any correlation at all, it'd be a very, very weak one. So in conclusion, age is not a factor when you're looking for a player's batting average that hit well. So this applies to only scouters that are in the MLB and not college, just because college is all the same age basically, and then it can't really determine whether their batting average is good based off of that.
And then for our third hypothesis test, I wanted to look at average runs and on-base percentage. Average runs is actually not a variable that Baseball Savant gave us. It was a variable that we had to create ourselves. Basically what this variable is the amount of runs a player scores divided by the amount of games they played. So that'll give us an estimate of how many runs per game they should score. And then on-base percentage is a common baseball statistic, which is how many times a player gets on base divided by their plate appearances. So that means walks, hits, runs, any way they can reach a base safely. And from these two variables, we get this graph, and you can see there's a little cluster there. So you can obviously see that there is a correlation of some sorts, and that just shows with our R value of 0.52688851. showing that there is a strong positive relationship between average runs and on-base percentage. And then on top of that, we used a correlation test and found a p-value that was very small, much smaller than our 5% rule. So that tells us we need to reject the null hypothesis. And it shows that there is a correlation between average runs and on-base percentage. So basically what this means for coaches and managers is that based upon how many times a player gets on base, they will tend to score more runs. And they can use that info to pick their players and decide who makes a roster.
All right, and so for our final hypothesis, I wanted to look at, does an increased salary incentivize players to work harder and score more runs? And so we've got that average runs variable, again, that Daniel was talking about, and then salary. And our salary ranges from $500,000 at the least to about $36 million at the highest. And from the graph, it doesn't quite look like, there's a huge correlation, but with our line of best fit and our R squared at about 0.3, we can see that there's a very weak linear positive relationship. And from our statistical tests, we can conclude that with a really small p-value, we can reject our null hypothesis. That means that salary and average runs are related. And so an increased salary is a necessary expenditure and may work to increase runs scored per game, and it's not something that's going to be a huge waste of money. And coaches or managers might then ask, well, salaries are high because, they're scoring a lot of runs, or are they scoring a lot of runs because we're now paying them a higher salary? And so whatever the answer is to that question doesn't really matter, because we can see that there is a relationship between a high salary and more runs scored. And so our key takeaways are that salary works as an incentive to increase player performance. High salary isn't an unnecessary expenditure.
All right, and then for mine, age and batting average has no correlation, so there should be no bias when signing or re-signing players.
And then position and batting average have no connection between the two, so players' positions don't affect the batting average.
And then the last key takeaway is average runs and on-base percentage do have a strong relationship, showing that the amount of times that a player gets on base, they will tend to score more runs.
Thank you.
Thank you.